So I think I should call to sir. Maybe he is somewhere busy. Actually, sir has called me that he is busy somewhere, so that's why he'll take my session at my place. So that's why we have simply swapped the sessions. Sathan sir, am I audible? So Silpa, I hope you have posted the attendance for this session, this last session, which actually I have taken.
Yes, sir. I have posted
Okay.
in the chat box.
Okay, all right.
Yes. Good evening, Dr. Ganesh. Am I audible to you?
Yeah, sir. Yeah, good evening, sir. Good evening. I was talking about yours only to the participants.
Yeah, that's okay. Then I joined when you were delivering the. I think you were almost to the last slide, but then I got disconnected for some reason. So,
Okay.
Abhi,
No
my
problem,
voice
sir. I was.
break or like is the connection okay? I want
Yeah,
to
it's
check out.
fine, sir. There is no problem. We
Okay,
are
voice
your
breaks नहीं हो
voice is
रहे हैं.
audible. नहीं, बिल्कुल
Audible
perfect है,
and
sir.
without breaks. ठीक है. That's okay.
I was talking to participants that sir has very good administrator also. He has very wide experience in renewable energy and have experience in renewable, I mean research and all.
नहीं
So
that
we have been worked under your supervision in the TechCube third also. So that was really great, sir.
yeah, that's true.
Yeah.
नहीं, I
So before
appreciate your
starting this,
connection. Mm-hmm.
yeah, sir. So actually, before starting the session, I wish to inform you, sir, that there are 100 around 80 participants registered in this faculty development program,
Oh,
and
that's wonderful.
yes, sir. So and the participants are from the various background. They are kind of multidisciplinary participants are there. Some maybe from computer science also, some mechanical, some are from civil engineering also,
Okay.
and I hope
All
that
right.
most of the participants are from electrical side. So, so before starting your session, I wish to cite your credentials or just like to read
Okay.
your bio. So,
All right.
dear,
Okay. Please go ahead.
yeah, please. So, but dear participants, I welcome you once again in the last session of the day. Professor Sasan sir is there with us, and he is the professor there at NIT Kurukshetra. Sir did his BTech, MTech, and PhD from NIT Kurukshetra, where he's currently working as a professor in the Department of Electrical Engineering. And he has guided and is guiding quite a good number of PhD around the areas of hybrid energy systems, microgrid and its control, evolutionary algorithms, intelligent control strategies, and their applications in hybrid renewable energy systems, so, which is actually the theme of this FDP. He has published more than 100 research articles in international, national journals and conferences of repute. Sir has very wide experience in administration. He has served as Dean Academics, Dean Students Welfare, and Coordinator TEQIP, TechCube Third at NIT Kurukshetra. At the national level, he has served for 3 years as the chairman of AICTE, New Delhi, and also as the visitor nominee for faculty selections at NIT across the country. He has also served as visitor nominee for faculty selections for Manipur Central University, Imphal, Chancellor nominee for Gujarat Technological University, Ahmedabad, and Dr. B.R. Ambedkar, Open University, Ahmedabad, Gujarat. He is member of the Academic Council of the Central University of Haryana, Mahendragarh, member of the Academic Council of NITER Bhopal, and has earlier served as member of Senate of NIT Silchar, member of Board of Governors, Government Engineering College, Bikaner, Rajasthan. Here, he is one of the designated expert on the AICT panel on NEP 2020. He is also serving on various high-level committees, bodies, task forces, boards as member chairman at the national level. He has traveled abroad to US, Australia, France, UAE, Canada, and Japan for various academic interactions and delivered talks in reputed international conferences. So this much of wide academic research and administrative experience. I welcome once again Professor Sathans sir here in this session. Some of the participants may have interacted in some way to Sathans sir earlier also, because as I can see here that as an administrator sir has been associated in many of the universities, many of the colleges through some committee members or some chairman. So many of the participants might be already knowing to sir. So I welcome you once again, sir, and I invite you to present your session, please.
Okay, thank you, Dr. Ganesh, and once again, a very good evening to all of you. Thank you for the very kind introduction. Although I am one of you in a way, I've been so very, nicely connected with the Engineering College Bikaner. I carry absolutely wonderful impression for all of you people there, and it's been a really good connect all during the TechIP project. And through the process, maybe some of the faculty of Bikaner Engineering College also might be possibly joined in here with you in the course. And,
Yes, sir. Yes, sir. Yeah,
all
yes, sir.
right.
Actually, many
And
people are there in the meeting from Engineering College Bikaner, and almost, or I must say, all of
okay.
them are knowing to you, because you have visited Bikaner, our
Yes,
college,
yes.
many times, and we have
Hello.
interacted with you every time.
Hello, Ganesh sir.
Yeah, yeah. Dharmender Singh is there.
Yeah.
Dharmender sir, mechanical from
Good evening,
mechanical.
sir. Good evening.
Okay.
Good evening, Sathans sir.
Yes. Yes. Good evening, Dr. Dharmender. Right. How are
How
you?
is sir? So it is quite
Good.
interesting
I'm
that
so
we are
good. In
meeting
fact, I'm so happy.
online again and
Yes.
interacting with you, sir. So
So we have
It's a pleasure always.
yes, sir. Yes, exactly, sir. Sir, I wish to
Hmm.
inform here one more thing. Actually, the interesting thing with this ATAL FDP is that we are having 50% of the experts from the industry. Actually, this time there was a mandate from the AICT that you must keep at least 50% of the participant experts from the industry,
Yes,
and
I could see.
two from overseas. So we are having experts from the various industries like BHEL. We are having
Hmm.
one more from MNRE. Another one is from Energy Efficiency Services Limited, Delhi, and one more is from some other place. And two overseas. Out of them, one is from Denmark. He will deliver tomorrow. Dr. Shubham Sahu from Aalborg University, Denmark, and another one is
Hmm.
from California. Dr. Kus Khanna is there. He is
Hmm.
working there in one of the industry which is associated with some smart cities and cyber security and all. So I hope this
Okay.
FDP will remain very much interesting for all the participants. So this was the thing which actually I
Yes.
wish to convey you.
Yes. Nee, I appreciate your efforts. In fact, I could see through the schedule actually, and I did see the kind of experts you're connected. It's really very wonderful actually, and I'm sure all these experts, they will, deliver a great deal to this theme, which is very important nowadays.
Yes.
And industry, yes, we should be knowing actually what are the challenges that the industry is facing in bringing this technology to the people. Whatever we are doing as research in our institutions or wherever, then how things are being implemented around renewable energy in the industry, and what are the products they're coming up with, and what are the challenges. So connecting almost 50% from the industry is a very good initiative. And even otherwise, I think you've connected with the people from academia also. They're very nice people, if I may say so, for all others except myself. I don't know, that's up to you. Okay, so and special good evening to all the faculty, the people connected from Engineering College Bikaner, always a special institution. I still carry this impression all along, and whenever I get a chance, obviously, to connect with you, I absolutely take that chance without even giving it a second thought. So, Engineering College Bikaner, especially those people who are there in this call, I say special good evening to all of you, and all others also. I was just like. I joined maybe around 7:29 or 7:28, I believe. And then I did see that Dr. Ganesh was still delivering the talk. He was like, I did see some figure there, with the graphical representation of certain results like LQR control and all. So that session, I'm sure, must have been very intense for all of you. And I have kept my session relatively, and it's in fact blessing the disguise that you have the diverse audience from different disciplines. So this talk is only, why at all do we need renewable energy, and how can we try and integrate that with the grid, and what is the way forward? So in that sense, if we see uh, that renewable energy is in fact very essential, and in the times to come, this is going to be the energy which will power the world, maybe almost 100% some 2-3 decades down the line. So that way, this topic, in fact, is or becomes essential for almost all disciplines to try and understand and how important is renewable energy for us on this planet. So this is not specifically only for electrical engineering. This relates to almost all disciplines. So with that background and with that kind of importance that we can attach to this renewable energy, I have my talk anyway scheduled, which is not that intensively around any particular research, control, statistics, or maybe some other area. It's in journal. The talk possibly you all will appreciate. And Dr. Ganesh, one request to you, by any chance, if I get disconnected for whatever reason, so please give me a call so that I get to know, or else, once I share my screen, then I may not be able to, get to know if I'm connected who, or else I got disconnected. So,
Yes, sure, sir, sure.
all right. So thank you. All of you, please stay relaxed and try and, be there with me all along. And I'll try and involve you also in between. There could be some questions for you. And those of you who have already interacted with me, I don't know, the way I deliver my talk, it's something like that. But then I think by the end of this talk, you will be in a position to appreciate uh, this talk possibly, and there'll be some takeaways for you that you can appreciate. Right. So thank you anyway. With that note, and continuing further this session, though it becomes 3 hours at a stretch without a break. This just happened without a break. I could understand that. But anyway, nevertheless, I'll try and see that you're all joyfully there in this session. I'll try and see that you don't suffer through me for sure. I promise you that. Okay, I'll try and make this session very interactive and possibly interesting for you. So give me a minute. I pull out my presentation. Let me. Just check out, someone's mic, I think, is unmuted. So please check. And Dr. Ganesh, see, there's some, I think, somebody is unmuted by chance. Yes, it's okay. So can you see the slides? Somebody can unmute and acknowledge and let me know whether you can see the slides. Is it visible to you?
No, sir.
Slides not visible?
Not visible, sir.
Not
Okay.
visible, sir.
Not
Okay,
visible.
okay, please. Okay, thank you, thank you. Just give me a minute, because okay, and information and this thing is available. Hmm. We can't display shared content. Make sure that you have allowed this permission to share content, and then try. Dr. Ganesh, you have given me the permission to share. Is it visible now?
No, sir. Yet not.
Yeah. Just a minute. What is the issue then? Let me. Just hold on. I don't know. It's showing simply connecting, and it's not actually connecting. If there's an issue with the connection, that also doesn't seem to be the problem. Have I been given the permission, Dr. Ganesh? If there's some issue regarding permission, or if somebody can check our screens, if we're able to say this at the time, share at this time. I cannot. Screen share.
Yes, it is visible now. Yes, yes, yes.
Okay, thank you. You can see it in the full screen.
Yes, sir.
All right, thank you anyway, and for the technical glitch, I don't know what it was, and my voice is reaching to without any breaks. It's clear to you all?
Yes,
Audible?
sir.
Yes,
Yes, sir.
Okay. Thank
yes,
you.
sir. It is clear.
So somehow, you got a anyway. That's possibly needed. All right. So this is how I've titled my presentation. Why perspective. So what is the importance, first of all, of a renewable energy, and why it is so important? Why are we all talking about renewable energy nowadays? In the past, maybe a little over a decade, close to 2 decades now. Earlier, it was not that much being discussed or being researched or being talked about. All right. So the idea goes around the Sustainable Development Goals. Right. I hope all of you must be knowing what are the Sustainable Development Goals, and how do we now talk around everything, not only energy, but in terms of almost everything. We try and relate to sustainability. We are concerned about sustainability, whether it's about energy, whether it's about water, whether it's about food, whether it's about any other resource for that matter. We, the people around the globe, now are concerned about its sustainable aspect, right? Whether it's simply so very important, that we try and see that whatever we do, whatever resource we use, whatever process we conduct, whatever product we manufacture, whichever way we live our life on this planet, it should all be sustainable, right? So the Sustainable Development Goals in 2015, the United Nations adopted these 17 Sustainable Development Goals, and the target was to achieve these goals by 2030. May not be achievable by that time, though. I mean, given the progress until now. But yes, the governments around around the globe, and the people, society, organization, industry, everything, and they're concerned about these goals, and these goals are around almost every aspect of our life. Right, energy is one of those goals, and these goals, once achieved, if not by 2030, but by whatever time they are capable of, and we will see a better world once these goals are achieved, in terms of ending the poverty, or maybe fighting inequality, or addressing the urgency of climate change, which anyway is very much talked about. And every year there are these conferences happening under the umbrella of United Nations in different countries to address the concerns of climate change. So guided by these goals we talk of, it's now up to all of us. That includes we as individuals and the governments around and the businesses and the industries around, the civil society and the general public, right, all put together to work towards achieving these goals, in a way towards building a better future for every one of us. Right, so sustainable development goals are that way very important to understand and also very important to achieve these goals. And in achieving these goals, it is not only the duty of the governments alone to be taking certain actions. Yes, the governments are taking actions, but also we as individuals also can contribute our bit, our iota, delta into this. Goal number 7, right? I picked up only this goal because this relates directly to. So goal number 7 is around affordable and clean energy. And if we go by the factual position as of now, in a way, so still there are 3 billion people, they still lack clean cooking fuels and technologies. And try if we can use only energy efficient appliances and light bulbs. This is anyway the goal. That is how it is mentioned on the United Nations website. So achieving affordable and clean energy is goal number, because energy is central to nearly every major challenge and opportunity. That's a punchline that's given there. And we also understand that we use energy day in, day out, using mobile phones or any other technology for that matter, that's around us in almost every aspect of life, right? That includes personal lives, that includes the industries around, that includes the agriculture sector, almost every sector. Without energy, we can't, imagine life. So when we say that renewable energy or clean energy is very essential, it's important. Try and understand what is renewable energy. This in a way is very general aspect of it, and everyone by now, obviously, with the very theme of this FDP, understands now what is renewable energy, right? The energy that provides the highest environmental benefit, and that says it all. Highest environmental benefit. So that does not damage the environment, that doesn't do any harm to the environment. What is that energy? Where from it all comes? Right, that comes from the power produced, let's say, through solar, through wind, exploiting the geothermal heat, biogas, low impact hydroelectric, and certain eligible biomass sources, tides, etc., etc. So all those sources, if you try and exploit and extract energy from them, so that does not damage the environment. So all those sources, in a way, could be bracketed under what is known as the renewable energy. All right. And these energy sources are renewable by nature itself, right? And readily available almost across the entire globe, including in any remote areas or for that matter in rural areas. Wherever you can think of on this globe, you have these resources available. Somewhere might be solar, solar to a great extent is available almost everywhere. But then if it's available, let's say there are not many sunny days around in a particular location, then at least they might be there. You have the wind energy potential available. Somehow, somewhere, you'll find some of the resources that are renewable in nature, and you can use those resources to generate electric power, or you can use them directly also to meet out your energy needs. So the aim here is to improve the overall environmental profile of the energy. Right? We have started worrying about our environment maybe in the recent decades, some 3-4 decades at the most, maybe 3 decades in a way. We've been concerned about the climate change. We've been concerned about the global warming, and because of that, the impact on the ecology, the impact on certain species. All of a sudden, right? The reason is that we've never bothered about nature. We've never bothered about the climate, actually, right? And we've been in that sense doing damage, doing in a way the violence against nature all along. And because of that, we have damaged the nature to the extent that we are now worried. We are now worried about sustainability. We are now worried about the climatic change and all, right? But anyway, it's never late. Whenever we can, we start working towards betterment of our nature, it's wonderful, it's good. And this renewable energy is going to play a key role, because most of these sustainability aspects, they are around energy. If we can try and see that, we can keep our nature safe and keep our nature in a better health and try and improve it eventually to the extent that it becomes the way it possibly was. This planet was maybe some 200 years ago, or maybe even prior to that, right? Because if we see, the life on this planet was sustainable only. Right. So, I mean, maybe 100, 200 years ago, or even prior to that, if you see, it was sustainable only. But we, the humans, no other biological creature, if we try and, do the introspection. So, who has done the most damage actually is the humans, so-called intelligent human beings. Though it's a question, maybe you can ponder on whether we are intelligent or not, but yes, we call ourselves as the most evolved form of species on this planet. And we are the ones who have damaged this planet, to the extent that we are talking now around renewable energy, sustainability, climate. But it's okay, fine. We try and understand that, and we realize it. Yes, if we've done the damage, can we try and reverse it? And can we try and improve and the climate on this planet, which is like, a wonderful one, which it was possibly. So then comes the question, right? We understand anyway, all of you understand what is renewable energy. Then why renewable energy? Why the need for? I mean, why do we all of a sudden, are so much so concerned about? The reasons is in a way well known: depleting fossil fuels. We understand we have, limited reserves of these fossil fuels, whether it's coal, maybe oil, maybe gas, or whatever. So there's a limited quantity available of these fossil fuels, and if we keep using these at the rate at which we are using them now, maybe these fuels would last maybe 100 years, maybe a little more than that, 150 years at the most. And then what after that? Once we do not have these fossil fuels, what will happen to? I mean, where from shall we get our energy needs fulfilled? So that's one of the important reasons: depleting fossil fuels. Okay. And the second concern is, or the reason is, the concern for environment, which possibly to me is maybe number one reason: concern for environment. All right. So we have damaged this environment on this planet to a great extent over all these decades. So can we think of now to reverse that trend, and can we bring this environment on this planet back to a very good one as it was? Now we're talking about AQIs, air quality index, and when possibly even when we were I don't know, kids, then also we never used to talk about, we never used to hear AQIs, air quality index, and air purifiers. Right. We are now talking, instead of water purifiers, now we're talking about, along with obviously air purifiers as well. How those purifiers are going to purify the air, which is anyway, let's say we talk of a metro city like Delhi, the kind of air, the quality of air that we have, on the outside, that's there. What is there to purify? And to what extent we can purify? So instead, if we can try, if we can contribute something as individuals and as governments, as businesses, can we try and take steps that can restore the environment, the purity of environment, what it was maybe 100, 200 years ago? So concern for environment is the most important reason to go in for renewable energy. All right. Then concern for sustainability. Okay, and that relates to the point number one also: depleting fossil fuels. Right. Our energy resources or sources should be sustainable. Right. Sustainability, when we talk of, that means whatever that's available to us as of now, to this generation, the same should be available, or maybe even better, to our next generation perpetually for all times to come. All resources, whatever that includes energy also, right, that are available to us comfortably, should be available to our future generations also for all times to come. So concern for sustainability in terms of energy is also one of the reasons to go in for renewable energy. All right. Okay, the central message is sustainability, and that's how your FDP is also titled or thematic around this word sustainability: renewable energy for sustainability. Okay, and just to put it in words, sustainability is nothing but meeting the needs of the present generation without compromising the ability of future generations to meet their needs equally well. Okay, if we have certain facilities, certain resources, then our future generations should also be, having those resources absolutely equally nicely. We should not be, eating on their resources, eating on the resources of future generations, whether it's water, whether it's energy, whether it's foods, whether it's anything else for that matter. So that's the central message, and that's where renewable energy connects absolutely nicely. Okay, so challenges concerning energy. I hope I'm there with you, right? I'm connected. Somebody can unmute and quickly tell me. Anyone?
Yes, sir.
Thank you. Challenges concerning energy. What are the challenges? What should we, try and look for? Where will that energy we need come from? Okay, that's a challenge, and that's anyways addressed through these resources. How much will it cost? That's also one of the important questions. Affordable, that was there in the Sustainable Development Goal, also mentioned. Affordable and clean energy. It should be affordable to the masses, right? So the cost of production of this energy should not be exorbitant, should not be, something, the general public cannot afford to. So how much will it cost? It should be available at a very reasonably cheaper cost. Will there be enough to sustain a rapidly expanding world where the energy demand is exponentially rising? Will that energy rapidly expanding, the energy needs are expanding, right? Especially for those economies that are growing, for instance, India for that matter, or maybe some other developing countries, right? The developed countries, anyway, they've used, absolutely extensively, maybe whatever energy we are using per capita, the people there in USA possibly they are using maybe 1,000 times that of us, or maybe 100 times, 500 times that of us. So the energy demands are growing. So in the expanding world where the energy demand is growing, exponentially rising, to be honest, will that energy be we'll be able to have that enough in terms of sustainability, right? And can it be harnessed with the least amount of harm to the environment, right? That's important. With the least amount of harm to the environment, if that energy resource can be harnessed. So these are some of the challenges that before us that we need to address to as academia, as maybe R&D organization, maybe industry, wherever we all are connected. There are some facts that you can appreciate. Today, the major portion of energy demand is met by using conventional sources or fossil fuels that we all understand, although the renewable energy share in the overall power mix, if you talk of electrical power, or for that matter, all put together, maybe direct use also. So the overall share of renewable energy is increasing at a very, very fast pace, right? And I'm confident and hopeful maybe decade down the line, 2 decades down the line, by 2050, I think we'll have almost, the entire world would be powered almost 100% through renewables. But these, so the major, portion of energy is coming through conventional sources as of now, and these conventional sources have the life that we've already discussed. They are limited in quantity, right? They are depleting. There'll be a day if we keep using at the same pace, when we'll not have these fossil fuels available to us. Cause these conventional sources, they do cause adverse impact on the environment by way of greenhouse gas emissions. And if you talk of greenhouse gases, CO2, carbon dioxide, constitutes primarily the major share of it, major portion, almost 75-76% of it is all greenhouse gases is carbon dioxide. So these fossil fuels, they result in the creation of CO2, carbon dioxide gas. The most abundant greenhouse gas, amounting for about 2/3 of greenhouse gases, is carbon dioxide, CO2, that we all know. Other greenhouse gases also, they are there. That includes, next in the proportion is methane, which is CH4, which comes from landfills, coal mines, agriculture, and oil and natural gas operations. So that's also next in proportion, the size. We have nitrous oxide N2O, which primarily comes from using the nitrogen fertilizers and certain industrial and waste management processes and burning fossil fuels. Okay, next SARE is that of high global warming potential, GWP, gases which are not naturally occurring, which are human made or man made industrial gases, right? And these gases, they do hold a potential to warm the globe very much, right? Very highly, kind of having the intensity to warm up the globe. So high global warming potential, these gases are the holding. And what are these industrial gases or man-made gases? That includes hydrofluorocarbons, HFCs, chlorofluorocarbon, CFCs, perfluorocarbons, PFCs, and sulfur hexafluoride, SF6, and nitrogen trifluoride. These are some of those gases, that are not naturally occurring but man-made and for industrial purposes primarily. Also, we do use, let's say, talk of our air conditioners and refrigerators and all. We are using these gases in them, right? And these gases, they hold a very strong potential of warming up the global temperature. So how greenhouse gases warm our planet? This is how we can see, and maybe you can appreciate. If we talk of carbon dioxide, for instance, so 1 unit, for example, of carbon dioxide, if that holds the potential of warming up, let's say this much, then methane vis-a-vis carbon dioxide holds a potential of 25 times more than carbon. Just one same unit of carbon, right? 1 unit of carbon, whatever quantity you can have, and 1 unit of methane. So methane can damage the environment 25 times more than that of carbon dioxide. Likewise, nitrous oxide holds a potential of 300 times. The same 1 unit of nitrous oxide is 300 times more dangerous than carbon dioxide. And these are the gases we're talking about, the man-made gases or industrial gases. Okay, fluorinated gases we've talked about, HFCs, CHCs, etc. They hold the potential of 1,000 to 10,000 times warming of the globe, the planet, compared to carbon dioxide. Just 1 unit of these gases, fluorinated gases, is 10,000, to the extent that 10,000 times, more dangerous compared to carbon dioxide gas. So you can imagine, and this is, the ratio in which these gases, they do occur on our planet. Carbon dioxide is almost 76%. Then methane is next up, that is 16%. Nitrous oxide is 6%, and fluorinated gases, the man-made gases, they are 2%, although just 2%, but then the kind of potential they hold for warming up the planet is, makes these gases really very dangerous. So if you can try and reduce these gases, we should try. Okay, and if we can try and reduce even CO2 emissions or all these emissions into the environment, we should try. And in fact, people and the governments, they're working towards, even in the industry also, is working towards reducing these gases emissions. Okay, so greenhouse gas emission by country, if you look at, these are some statistics that you can simply, out of interest, I thought I just I put up these in these slides. You can appreciate that we do have say the China topping up on this list. 30% of the entire greenhouse gases emissions is coming from China alone. Then United States is something around 15%. All 28 countries, European Union put together, is 9%. India is 7%. Obviously, we are also, we being a growing economy, we also contribute some 7%. Russian Federation is just 5%. Japan 4%. And the rest all countries put together is 30%. Okay, so it's China that is at the top of this list. Greenhouse gas emission by sector. Which sector is contributing how much to these greenhouse gases? We do have energy sector primarily contributing. That includes power generation, wherever we do need energy, say transportation, manufacturing, construction, industry, electricity, and fugitive emissions. So all put together something around 68.7%. Then agriculture sector is also contributing by 19.6%. Then industrial processes 6%. Land use change in forestry and waste, that's 1.9%. Okay, sector-wise. So it's primarily the energy sector that contributes the most of these greenhouse gases. Effects of greenhouse gases, we will understand climate change. We have been talking a lot, and every year there are these conference of parties, COPs being held up. I think this was last time. It was 28 conference of parties that was held this year. Then we do have global warming as a result of these gases. Then adverse impact on ecology. The very, some of the species, they, are at the level of extinction in a way because of this global warming, temperature rise, etc., etc. So even the ecology is getting affected by these greenhouse gases, and there could be multiple other impacts of these gases on the climate and on the life as such, as we understand on this planet. So because of these very adverse impacts, the world community is showing its resolve to reduce these emissions of greenhouse gases. And how it is happening is under the umbrella of United Nations. And the world summits are taking place on climate change every year. And the government heads from various different countries, they are coming to those conferences and trying and maybe coming with certain measures. And notable of those world summits is on Earth Day, that is 22nd of April 2016, 175 world leaders signed the Paris Agreement. So that's very notable one. The Paris Agreement signed by 175 countries on 22nd April 2016 at United Nations headquarters in New York. This was by far the largest number of countries ever to sign an international agreement on a single day. So we can understand the kind of gravity, right, or the kind of importance the climate change is given by these countries all put together, right? People are concerned, people are, having their targets defined during these conferences, and every country then works towards achieving those targets to reduce these carbon emissions. Right. So, which has been subsequently ratified by many other countries. So 175 countries, they signed on the same day there itself, and subsequently ratified by other countries also. So this agreement came into effect on 4th November 2016 and adopted at COP21 in Paris Conference of Parties, we call it as, on 12th of December 2015. And the goal to keep, what is the goal of this agreement? To keep global temperature rise well below 2 degrees Celsius pre-industrial levels, and to pursue a path to limit warming to 1.5 degree Celsius, well below 2 degrees Celsius pre-industrial levels. When we talk of industrial revolution, that was 1940-45, around Second World War. So the global temperature, whatever it was then, can we bring it down even 2 degree compared to that threshold level as well? Okay, here are some questions, and very simple ones for all of you. Any one of you can unmute and tell me the answer quickly, right? This is just to excite you around. Okay, are greenhouse gases required at all? That's a question. It's just a yes or a no question. Yes. Anyone can unmute and tell me, are greenhouse gases required at all? Yes or a no? Hello, am I there with you?
No, sir.
Is I'm there with you?
Yes, sir.
हाँ, इसका आंसर क्या होगा? Yes or no?
No.
No. Okay. One more, three options, right? One option you say you please identify yourself and then tell me, yes, so and so from so and so institution, and then tell me the answer. Yes, who was the one who said no now? Yes, gentlemen, where from you are? Because I can't see you, I just can see the slide only. So if you can tell me, I'm so and so from so and so institution, and my answer is yes or no, I mean, whatever. Hello. Right or wrong doesn't matter. Hello. Galat theek is not my concern. You just respond to. I'll appreciate your
Sir,
response.
this is Suman from Anurag Engineering College, Telangana. My answer is no.
All right. All right. Thank you, Suman. Thank you. I listened to some other people also. But Suman said the answer is no. Anybody else? as a different
Yeah,
opinion?
hello.
Yes.
Yeah, sir, this side Subodh Bansal from Chandigarh University.
All right, please, Subodh, tell me.
Yes, sir. According to me, these gases are required, and because life on the Earth will
Okay.
not be possible without these gases.
Okay, so from you say, okay, yes, these are required. And
Yeah.
Suman said not required. All right, let's see. Let's see the answer. Okay, two options is sufficient. Okay, the answer is yes. Yes, these gases, Suman, are required. You know, these gases are essential also. We can't do without. Okay, and I'll let you know, maybe there are other questions that will let you know why these gases are essential for us. Okay. Next question. Now, what is that question? Do greenhouse gases occur naturally? Again, yes or no question. Anyone?
Yes, sir. And this side Anshu more than all, and it are required. Sir, they are actually naturally.
Yes, they do occur naturally. That's your answer? Okay,
Yes,
correct.
sir.
Correct. I mean, we do have these, some of these greenhouse gases occurring naturally. For example, CO2 or maybe methane or even nitrous oxide, right? We do have these gases occurring naturally, and also industrial man-made gases as well. They are okay. Do all greenhouse gases occur naturally? I mean, a very simple question though. Yes or no?
No, sir.
No. Okay, that's very true. No, because there are some man-made gases also, the fluorinated gases we're talking about. So it's not that all greenhouse gases they do occur naturally. There are other man-made gases as well. Okay. Next question. What if there are no greenhouse gases? This is not a yes or a no question. It's kind of a descriptive one. Maybe somebody can like try and explain. What if there are no greenhouse gases on this planet? Yes. Yes. Anyone, please unmute and tell me who that person is, and then you can respond.
सर दिस साइड अगेन अंशु एंड आई जैसे कि अपन CO2 की बात करते हैं सर CO2 एक ग्रीन हाउस गैस है बट वो भी
Yes.
मतलब जरूरी है सर CO2 अपने ऑक्सीजन के O3 के लिए भी और ऑक्सीजन जो अपन मतलब फोटोसिंथेसिस के थ्रू बनता है सर और ये
Okay.
अपन इस पे बात करें सर मतलब वाटर बॉडीज की तो वहां पे इवोपरेशन होता है जिससे वाटर वो
Mhm.
मतलब H2O ड्रॉपलेट्स बनते हैं सर उसी के बाद रेनी सीजन्स आते हैं तो वो रेन होता है वो उस वजह से वो भी जरूरी है
Mhm.
सर
Okay. चलिए, yes, I appreciate all the discussion that whatever you say, thoughts, बिल्कुल ठीक है. But then the question is, what if there are no greenhouse gases? यदि नहीं है तो क्या होगा? चलिए, जरूरी है, but यदि नहीं है, then what will
सर
happen?
अगर अगर ये नहीं होगा तो फिर हम ऑक्सीजन पे ही तो लिविंग बींग्स तो ऑक्सीजन पे ही डिपेंड करते हैं अपना वो मेन सोर्स
Mhm.
नहीं रहेगा सर ब्रीदिंग का और फिर रेनी सीजन भी सर अपने इसके एग्रीकल्चर के लिए मोस्ट इम्पोर्टेंट है बट अगर वो नहीं रहेगा फिर रेनी मतलब कि एक तरीके से एग्रीकल्चर
Mhm.
इंडस्ट्री भी खत्म होगी सर
That's right. Thank you. I appreciate your viewpoint. One more viewpoint, by the way. Anyone else also? Let's take one more response, and then
CO2 is a
yes,
greenhouse. Sir,
yeah, yes,
CO2 is a greenhouse gas.
yes.
So if it is not in the environment, it will affect the life cycle of the vegetation and any other greeneries.
Okay. That's true. I mean, these gases are required. That's very important. That's true, right? For the life as we know on this planet to happen, these gases are needed actually. And okay, मेरा क्वेश्चन ये था, चलिए, if अगर ये gases नहीं हैं, then what can happen? Like, for example, we don't have these greenhouse gases, including CO2 or for that matter, कोई भी, तो क्या होगा?
So instead of increasing the temperature may decrease exponentially.
Okay.
Yeah.
Who's that?
Subodh Bansal this side from Chandigarh University.
Okay, Subodh Bansal from Chandigarh University, right? Okay, Subodh. So Fine, that's true. So let me show you the answer. Let us see what it is actually. Can you see the answer written in green? The greenhouse gases in the air, what do they do? Trap the radiation from the sun and act like a thermal blanket around the planet. Okay. And this effect, what is this effect? Without the greenhouse gas, it is basically this energy available. I mean, the kind of temperature that is maintained on this planet is because of these greenhouse gases only. Okay. And this, because of that, it's in a way the thermal blanket around the planet, and without the greenhouse effect, that's what, greenhouse effect is very essential for that matter. So without the greenhouse effect, the earth would have an average temperature of minus 18 degrees Celsius and would be covered in ice all through. And life, as we know, will not be possible, will not be able to survive on this planet then. Right? So if there are no greenhouse gases, then life as such that we are having will not be possible. Okay? So these gases are the ones responsible for trapping the sun's radiation energy, that the radiation that are coming to the Earth's surface, then they are getting reflected back. So they are being trapped, some energy. And that's how it is. It's in a way the thermal blanket. So these are gases, and these are essential for us, all the greenhouse gases. Okay, maybe just one last question. If the greenhouse gases are required for survival, then where's the problem? Yes, we all have now come to the conclusion out of these all questions that yes, greenhouse gases are required for survival. So what is the issue then, and why are we worried then? Yes, anyone? Again, descriptive response. Please do respond. Anyone? Hello? Students भी होंगे इसमें, I believe. Some students, scholars, research scholars, faculty, like it's a diverse mix. So anybody can respond to, I mean, as per the thought.
Sir, the reverse thing will happen, sir.
What?
The previous question, the temperature will get down, sir. The
No,
same
that's
thing,
okay. That's okay.
opposite to this, it will happen here. The temperature will get increase, so that the frozen ice will get melt, so the water level will get increase.
Right. So the problem lies where? The problem lies where? If the greenhouse gases are required, we understand.
Yeah.
So where's the
sir,
problem?
I think average should be there.
Amount
Like
of
temperature
gases.
should not be more or it should not be less. The average temperature should be there, like for the existence.
So one thing is important, that we do need greenhouse gases. Now the problem lies in their concentration, the quantity, the problem lies in their concentration. How much greenhouse gases, right? There was a perfect balance on this planet. And if you talk of maybe 100, 200 years ago, the naturally occurring greenhouse gases, and maybe by certain other process, whatever. So they were in perfect balance to maintain the temperature around this planet, around this globe, as it should have been. Now we are, these man-made processes, also these industrial processes, man-made, I mean, these activities that we perform on our daily life, that has increased the concentration of these greenhouse gases in the atmosphere. Right. So problem is not their existence, not the existence of these greenhouse gases, but the concentration that is increasing like anything. So which is constant in the rise also, and that is the problem. Right. We try and reduce this concentration, try and reduce these greenhouse gases, and bring in at a point which maintains the balance. Okay. If and there was a perfect balance on this planet, to be honest, but then we increased by certain activities, certain processes, the concentration of these gases. So the problem lies here in the concentration of these gases. Okay, the quantity of these gases, that's little too much. That's little too much, and it's increasing. So that's where the issue is. Okay, so what is the alternative? The alternative is, what is the answer? Hello. The answer is renewable energy, right? And that's what we are here discussing, right? So this renewable energy is trying ensuring, because major chunk of these greenhouse gases coming through the conventional fossil fuels, the kind of energy we are using, kind of activity we are conducting. So we can try and arrest those kind of activities, or try and provide an alternative, which is renewable energy. So that can address the problem of greenhouse gases to a major extent. Okay, India is a country blessed by nature. When I say this, India is a country blessed by nature, truly blessed by nature. All right, what do I mean by that? And specifically in terms of renewable energy, not only in terms of renewable energy, but yes, to a major extent in terms of renewable energy. We do have, with 300 clear sunny days in a year, right? Whole lot of potential for solar energy, for solar power, right? There are countries wherein you don't have a clear sun available, maybe for months together, right? So we, in that sense, are really very blessed. Almost across the entire geography of our country, we do have a huge potential of solar energy. Okay. Next, over a dozen perennial rivers, right? More than a dozen, there are these rivers that flow all through the year. A whole lot of potential for hydropower. Okay. And a coastline of more than 7,500 kilometers. Okay. That means a lot of potential of wind energy along the coastline. And there are these countries that are landlocked. They do not have any coastline at all. They don't touch the sea. Right. So if you look at India, our country, truly speaking, is blessed by nature. Look at the potential that we do have in terms of solar energy, in terms of hydropowers, in terms of wind energy. Okay. So that way, and we have, almost every geography in our country, right from the peaky mountains, wherein we do have all time covered with snow. Okay. Down to the plains, Gangetic plains and all that, and the coastline. Right. So anything that can be grown anywhere on this planet can be grown in our country. Right. So all kind of climatic conditions are available. Right. There are countries wherein kind of 6 months almost the same kind of climatic condition. Hardly, there is the visibility of sun available. So in that sense, we as a country are really very blessed by nature. And how do we try and make use of that blessing is up to us all. Right. And possibly, now, the government is taking wonderful initiatives in terms of renewable energy, and or also in terms of making good use of these resources available whatever it is. Okay. And very proactively, we are moving towards a developed economy, and soon we should be achieving that. So India has got huge potential of renewable energy, and so much so that we'll move into a fully renewable electricity system by 2050. It is expected, and we would be possibly even prior to that. Okay, if you look at India at night from space, this is how it looks like. That means we are using energy day in and day out. Maybe it's around Diwali, maybe, I don't know. So too much of bright lights available. But even without Diwali also, like every country, though not only in India, this slide is only to make you appreciate the fact that we do use energy not only in the daytime but in the nighttime as well, almost every minute, every hour. World energy consumption, if you look at, this is how it's been going. Okay, this data is little old, but yes, the response and these, you can further extrapolate this. The major chunk of energy has been coming through oil at number one from the very previous decades until around 2010, and the share of renewable energy has been almost minimal, very low. But then after 2010, it's very steep slope if you look at, and beyond 2020 it will be even better, right? So this renewable energy is catching up very fast, but it was oil, and then still it's there, then coal next up, then natural gas, then hydro, nuclear, and other renewable energy. Okay, so this is how the world energy consumption is, the pattern. How much longer can we depend on fossil fuels? That I think we've already discussed, because these fossil fuels, they do have their life, and at the same rate that we are consuming, if we keep, though and I'm sure, we'll stop using these fossil fuels while we'll have sufficient reserves of these fossil fuels, right? Because of these all concerns of environment and all, and we'll have sufficient renewable energy available, so that we'll not be required to use these fossil fuels at all. While we still have these reserves available, we'll stop using them. So there'll be a time, there'll be a day soon, and some 2050 or 2060 at the most. All right. So this fossil fuel is possibly will be over, just like the Stone Age got over, not for want of stones, but for the reason that we evolved around the other technologies. The global temperature anomaly, if you look at this, this is how the annual mean and 5-year smoothing, if you look at the red curve shows this pattern of global temperature rise and fall maybe. So 1880, if you look at this temperature versus the baseline, if you see, it is on the decline and goes little up, then again falls. So from 1900 down to 1910 or so, it was a decline there. Then after it is increasing, if you look at, and around 1940-45, where the industrial revolution took place, World War II, because a lot of industrial activities that resulted in global temperature rise a little too much, and then after it is, such a steep rise. Look at this, right? 2020, and if we keep on moving at the same pace, then things will be very difficult, and due to climate change, there'll be so many things happening, right? And the fact remains that if you don't take care of nature, for sure, we'll be in trouble. With no amount of technology, we can win over nature to be. Let's be very clear on that, right? However developed we may be, whatever kind of technology we might be having, but no technology, will come to our rescue if nature takes its toll, right? So the only way out is, if we cannot win over nature by technology, so what is the way out? The only way out is we can peacefully coexist with nature. We try and see that the kind of technology we do, kind of processes that we kind of resource we consume, kind of industrial process we carry out, all and everything should be around sustainability. Everything should be around while we take good care of nature. All right. And that includes our lifestyle, that includes the way we consume energy, that includes the way we eat our foods, that includes everything in that sense. So let's be caring to nature. That's an important message, right, out of this discussion. Let's be caring to nature. We've been doing violence against nature, to be honest, and that's how these all temperature anomalies, that's how these steep rise and all, right? We've been a little selfish around the humans only, but there are other birds, flora, fauna on this planet. There are other species on this planet. This planet very much belongs to them as well. It's not only humans. So let's all be kind and caring to all the species, to the nature, and in turn nature will take good care of us. Let's be realizing this fact. Okay. And when we say caring for nature, we all can understand how can we take good care of nature. That includes trying and making judicious use of energy, trying and seeing that we do not pollute any of the water bodies, or we do not litter around, we don't create kind of anything or any activity, conduct any activity that can damage the environment in any way, for that matter. Maybe single-use plastics or anything for that matter. Okay. And if that be the case, we'll be really healthy, we'll be a wonderful life on this planet. Carbon emission by conventional energy sources, that's again a very passing slide. It's okay, we can simply appreciate by the conventional sources. If you look at the countries, which country is contributing to these carbon emissions the most, it was United States, this kind of yellow line, until around 2010 or so, 2005 or so. Then after China, surpassed this, and it's China now at number 1 in carbon emissions. Okay, then European Union, the green line, then India, which is of late has picked up because of the activities that are taking place. We are developing nation, we are growing economy. So there are these industrial activities and all other activities, infrastructure development, etc., etc. So we are also now contributing to this carbon emission. Then Japan is kind of consistent, steady only. Then international shipping and aviation, and these other countries, this black dot. Okay, these are some of the countries contributing to. India's renewable energy capacity hits 200 gigawatt milestone. When it was, right, that source is renewable energy, Ministry of New Renewable Energy, October 14, 2024. 200 gigawatt milestone. That's really, really huge. And that's in a way constituting something around 46.3% of the total capacity. That's a remarkable milestone. As of October 2024, India's total electricity generation capacity stood at 452.69 gigawatt. And out of that, 200 gigawatt coming through renewable alone. It's really, really very wonderful. Okay. And maybe we'll, soon achieve that almost 100% energy power coming through renewables. Okay, renewable energy capacity in India, solar, out of that, renewable, this total share is, that of solar power is something around 45.1%. Hydro, that includes hydro though, is 46.92%, wind power 47.3%, small hydro and biopower, that is 5.6%. Okay. Top 10 countries using renewable energy resources. Leading countries that have the installed capacity of renewable energy. And the data is little old, 2021 in gigawatts. China was number one, 1020 gigawatt. That's really, really very huge. And then US 325 gigawatt, Brazil 160, India 147. That was in 2021. 2024, it's already gone up to 200. And as of now, I think 1 year down the line, it must be somewhere around 230, 220, 230 gigawatt or so. Then Germany, Japan, Canada, France, Italy, Russia, etc., etc. Renewable power capacity additions, if you look at, initially, if you see 2012, this yellow is for solar, then wind is blue, and then hydro is green, and then biopower, geothermal, ocean power, and CSP, concentrated solar power, that uses the reflectors placed around in the field, and they're targeting that incident beam onto a central tower like that. So direct use of solar energy, that's CSP. So this was 2012, and if you look at 2018, look at the solar power, which is very minimal here. It's gone such high, and wind power also. So this addition of the renewable energy in a particular year is really, really, very much. Say annual additions, if you look at of renewable energy power by technology, then 315 gigawatt alone in 2021. And that was the power added in just 1 year, which possibly if you go back 2016 or maybe 15, the total capacity of the world all put together must not have been around this. And this much is getting added, right, in just 1 year. And 2050, by 2030, we expect the net zero scenario by 2030 and beyond in certain countries. Renewable power additions must triple to be on the track with major net zero scenarios. So it's in fact all over the world, people, the countries, they are generating a lot of renewable energy, and they're adding to their capacity very hugely. How much renewable energy each country will consume in 2030 is just a glimpse of it. By 2030, for instance, China should be consuming of the total renewable energy world over. 20% of it, China would alone be consuming possibly. India 9%, European Union as a whole put together some 14%, USA 15%, Brazil 7%, and like that. Okay. Installed capacity for renewable energy power generation by technology, if you see, and then it is 2014 baseline is with the blue color, and a reference case and a renewable energy roadmap. I mean the ideal case. If you look at coal, natural gas, nuclear, leave it out. Simply, if you look at the 2014 case, this is 180 solar. This is 180, for instance. And then the reference case is we are targeting 780, And if everything goes very fine and people double up on their efforts, then we can go even up to 1760, right? By 2030. That's the potential, that's there. Hydro 2014 baseline 1020, and 2030 it should be 1530. That's a reference that we are going around. Potential we can go up to 1670. So there's a huge potential of these wind also, right? 370 gigawatt installed capacity in 2014, right? 370 gigawatt. In 2030, the reference we are targeting it to be 1070 in the world all put together. Though if we put in more efforts, we can go up to 1990 gigawatt by 2030. Wind alone, and solar is something like this, and hydro is something like that. Then bioenergy also, and all these geothermal, etc., etc. Okay, here's a question for you. Wonderful. That makes you a little attentive. This anyway is the old data, so but anyway, I can reconfigure this question. Okay, let's talk about that only. What was the target India set for itself in terms of total power generation through renewable sources by 2022? That's gone by though, and we've achieved the target. What it was, by the way, if somebody of you know it, right? Then we'll talk about the target of maybe 2030.
35%.
How much?
35.
How much gigawatt?
Yes, let me work out, sir.
India, had set a target for itself that these many gigawatt to be achieved by 2022. What was that power in terms of gigawatt from renewables? The target set by and achieved also. Yes, anyone?
Approximately 400.
Approximately 400 gigawatt. No, not exactly, because I just shared with you the statistics that in
160, sir, 160.
160?
142, 160 gigawatts.
140 to 160 gigawatts, somewhere in this window.
Sir, 175.
Yes, 175 to be exact and precise. The target was of 175 gigawatt by
Yes, sir.
2022. And fortunately, we could achieve the target. Okay.
Yes, sir. Yes.
So 175 was the target set for. Okay, there's another question. Okay, wonderful. What was the breakup of this 175 power targeted to be generated from renewable sources by 2022? How much power to come from which source?
100, sir. 100 powers from renewable and 50 from wind and 60 from bio. Sorry. 100 from renewable source. 60.
100 from solar. 100 from solar. Okay.
Yes, sir. 100 from solars and I think 60 from bio and 15 from wind energy.
Okay, who's that, by the way? Can you identify yourself?
Yes, sir. I am not audible, sir.
And who's that? You please tell me your name and where from you are, which institution?
Oh, sir, my name is Pratima Patnaik. I am from Bhubaneswar, Odisha. And
all right. Okay. So let us see, Dr. Pratima.
Yes.
Whether you're correct or not. Okay, 100 gigawatt from solar, right? You're right. 60 gigawatt from wind. You were a little confused around biomass and wind, I believe.
Yes. Actually, I'm third confused.
No, it's okay. This happens anyway. 60 gigawatt from wind and 10 gigawatt from biomass and 5 gigawatt from small hydropower. So that was the total composition of this 175 gigawatt to be achieved by 2022. And we did achieve in a way the next 2 years down the line. By 24 October, we could achieve 200 gigawatt target. So that was the one. And there is this, anyway, what is the target by 2030? This is target for 2030 also.
Yes.
India has set up a target to achieve in terms of renewable energy. this much gigawatt by 2030, 2030. That is 500 gigawatt. I mean, it's a huge target, right? We'll achieve it. Okay. Estimated direct and indirect jobs in renewable energy sector by country and by technology. There's a huge potential of renewable energy sector in the times to come, and there'll be huge openings available for our graduates and for the researchers, for every one of us in terms of the job opportunities. If you look at solar PV alone, world over, in thousands, so 3,000 jobs. Not only three, but let's say if we say 3,000 jobs in solar energy alone, wherein China would be the top, Brazil something around 4,000 jobs, in India also somewhere 121,000 jobs. That's a potential, of these sectors. Liquid biofuels, wind power. Say India, we do have something around where it's like 60.5 thousand jobs available alone in wind power. So this sector holds huge potential for job opportunities for our youth in the times to come. This slide was only to appreciate that. Global renewable energy employment by technology, if you look at, right, something around 12 million people, they are employed in renewable energy in 2020 alone, and it's on the rise. Okay. Some of these data are longest uninterrupted stretch with 100% plus renewable electricity. Selected countries or regions, in certain selected countries. So they've been these many days 100% powered through renewable energy. Let's say if we talk about Austria, 35 hours and some 68 hours. These are some patches, wherein the entire country, this region was powered through renewables alone. Costa Rica, that's a place, 76 days in 2016 at a stretch, there was completely powered through renewables. 299 days later on, somewhere in 2021, this in 2016. And South Australia, right, 116 hours and 156 hours in 2021. So entire South Australia was powered through renewables. And there are these countries wherein they pay you also for consuming to maintain the grid balance, right? Otherwise, if the generation is more and consumption is less, there's an issue, or vice versa also. You're generating less and load is more, so this frequency is going to go down, and generating more and you're consuming less. So this load and frequency balance is very important. You might have studied also load frequency control. That's all about this maintaining generation and consumption balance. So there are these some countries wherein the renewable energy is a little too much, and they do pay the consumers for consuming electricity just to maintain this power grid balance. Okay, solar power is where I'll touch, and possibly, if time permits, we'll try and close in the next some 5-10 minutes. Solar power, as we all understand, is the energy coming through the radiant solar energy, and that's the chemistry of it all. The radiations, they comprise such and such things. Okay. Then major uses of solar energy, direct use also for the heating purposes, not only for heating water, but also for heating our homes, in certain cold regions. Space heating, that's what I was talking about, for heating water, for space heating, and for generating electrical energy through solar photovoltaics. And some of the solar technologies, we use solar energy obviously for daylighting, passive solar heating, and concentrating solar thermal. That's you have your solar reflectors placed around the field, and that also used for heating a particular central tower, and to the extent maybe 516 degrees Celsius. Therefrom, you try and use that heat to produce steam and then generate electricity. Then photovoltaics also you can use this solar energy for. Day lighting, okay, maybe for passive solar heating. These are some of the houses, the way you construct to let the energy get in. This is what is your CSP, concentrated solar power, and these are the solar reflectors placed in a field. And this is a central tower. They're targeting their energy. Let's say, there's certain lens you might have used in a school times, that if you focus, it'll burn a particular thing. So this is how it is. Then the solar photovoltaics. Passive solar, just like we have solar heating of these, lot of use of the glasses in certain house constructions. These are, the design of some of the homes in Montana and California, with a passive solar design heats the home in winter season. And that's how also could be using solar energy. Maybe there's a video that plays here for you to appreciate. Okay, let us see if it plays.
Our city depends on electricity. By burning fossil fuels like coal, diesel, and natural gas, we are able to generate electricity from steam turbines. But what happens when we deplete these limited resources? Without fuel, there won't be enough electricity to power central Luzon. There will be brownouts, hospital equipment will shut down, streets will be dark and dangerous, electronic communications will be disabled, businesses will be paralyzed, and children won't get the quality of education they deserve. These will become long-term blackouts, affecting their lives and slowing the progress of growing cities in central Luzon. But hope shines above us. The infinite power of the sun. So how can we harness this power? These are solar cells. They can convert light energy into electricity. Each cell contains two pieces of silicon, one that is negatively charged and another that is positive. When light particles collide with the negatively charged silicon, electrons fall and get attracted to the positively charged silicon. As electrons travel from silicon to silicon, they create a current, which we call direct current electricity, or DC. This is the type of electricity found in battery. A number of solar cells connected to each other and mounted in a frame is called a module. Each module is designed to generate about 30 volts DC. To generate large amounts of electricity, modules are grouped together to form an array. These are scattered throughout an open field to capture as much solar power as possible. But this electricity is still not ready for public use. It needs to be converted to match the type of electricity needed by home appliances. That's why solar power plants have inverters and transformers. The inverter converts the single current direction of DC electricity to multiple directions of alternating current, or AC. The electricity then flows to the transformer and boosts it to 13,800 volts to reduce power loss when electricity is transmitted to far distances. From the transformer, electricity flows to a substation. This regulates electricity to usable 220 volts using another transformer and distributes power to homes. This is how the Suhag solar power plant in Mexico, Pampanga, works. It generates about 10 megawatts of electricity that can power almost 9,000 households or 5 barangays. Unlike fossil fuel plants, which can be depleted and produces carbon emissions that harm the environment, Suhag runs on 100% renewable energy from the sun. In time,
Okay, so this was just a small video for you to appreciate the solar energy and how it gets converted from the through PV into electricity power. So there are certain advantages of solar energy. It's clean, obviously. Yes, it comes to us directly through nature from the energy of the sun. Sustainable, can be used for longer duration. I mean, sustainable till the time there's sun energy available, there's life on this planet. If there's no sun, there won't be any life at all. So it is sustainable perpetually till the time there's life on this planet. Provide electricity to remote places. Yes, we can. If the grid is not possible, in certain location, in certain remote areas, to lay down the grid, maybe you can have the islanded solar PV kind of a power generation facility that can provide electricity to the remote places. Free of cost, yes, it doesn't cost us anything in that sense. It's freely available to, and almost on the entire geography of this planet. Then there are certain negatives also. What are the negatives of the solar energy? This is inefficient. I mean, and that's also and that's one of the disadvantages. Maximum efficiency of these solar PV cells attainable till date until now it's something around 30%. It was around 19, 20, 21, 2 and all. So practically it's still under 30 though, but maximum in certain labs it's around 30%. Costly equipment, yes, PV solar cells etc. used to be, but this is as of now is not a disadvantage in a way because of the research and the evolving technologies that's taking place in this area. The cost of these equipments has drastically come down, so that no more remains a disadvantage. It used to be, yes. Part-time, that is the key point here. You know, this energy is available to us intermittently. It's weather dependent in a way, right? If there is a clear sun available, wonderful. But suddenly if it becomes, you know, dark and dusky, maybe there are a whole lot of, you know, dark clouds, you don't have the sun available and you don't have that energy available. And supposing if there is a particular area, maybe a locality being powered purely through solar, and in the rainy season or maybe in certain seasons, suddenly for a day altogether, if it's cloudy and very dark clouds, and maybe whatever the power, maybe some 2 gigawatt, maybe 200 megawatts suddenly goes zero, or maybe 200 gets reduced to some 20. So this intermittent nature, unpredictability of weather conditions, that is one of the major disadvantages of this solar energy. Solar resource map of India, if you look at red color shows it all. There's a huge potential of solar energy almost over the entire country, over the entire geography of our country. So that's a wonderful you know, potential. Solar PV global capacity and annual additions, this is just for you to make, you know, sense. 303 gigawatts in 2016, again little old data it stands at, but as of now must be some almost 10 years down, must be really huge. In 2016, 75 gigawatt alone was added, wherein maybe China must have been at the top. All right, China accounted for almost 46% of the new capacity addition in 2016. This slide is little old, please excuse me for that. Okay, there's a question for you, and with that question, and maybe I don't know if time permits, I can go on further some 10 minutes, but then I'll try and close it so that you don't suffer. As I promised you, I'll not make you suffer through me. Till the time you're enjoying it joyful, it's wonderful, and I believe until now you've been happily around me and with me connected in this presentation. Let's see if anyone can tell me where's the world's biggest solar power plant. You there with me? Hello? Somebody can unmute and let me know. Then I make you free, don't worry. Okay? I'll check out with you in case you have some questions, and then I'll close the session.
Sir, answer this question. I think China.
China? Okay.
Yes.
Which solar plant there in China?
Sir, actually, I don't know, but I think China is the biggest solar plant.
Yes, the general impression goes like that. It must be China. That's how. Because it's producing a lot of solar PV power, a lot of renewable energy.
Yes.
Okay. Anyone else?
Sir, it's in Gujarat. I think it's owned by Adani Group.
Okay, and let us see if it is in Gujarat.
Sir, I think it is in Rajasthan.
Yes, that's
that is
Bardla
Bardla solar plant.
Is it in
That's
Bhadla?
yes, with a capacity of 2,245 gigawatt. There were these two individual solar power parks. They were combined together, and until 2020 March or so, it was China only, some Guangzhou or some place. But then thereafter, and maybe after that, maybe some other plant might have come up. I'm not aware, to be honest. But this was until recently the one which is the biggest solar power plant in the world. That was in Rajasthan. Okay. And if there's any other further development, maybe you can update me on, or else you can check out that. But yes, it's something we can take pride in that our country is contributing or growing really very extensively in renewable energy. Just to share with you, at NIT Kurukshetra, we do also have rooftop solar power installations of 1 gigawatt operational for the last 6 years, right? And we are coming up with additional 1.5 gigawatt in maybe a year or two. And our total requirement is something around 4 megawatt. So if we come up with maybe two more installations of some 1.5, we'll be self-sufficient in power, kind of, net zero. So all institutions should try and have these facilities, even households also. That's really very economically advantageous to all of us if we can have solar power installations. And these solar modules are coming up at a very reasonable cost now. Fine. So shall I continue or shall I stop? I don't know. You just let me know, or else I do have certain. Maybe I can finish at this point in time, or else maybe I can quickly take this tidal power. Your choice. If you're receiving nicely, it's good. If you're still receptive, it's wonderful. Or else I can stop here also, not a problem. And we can take up some questions. And Dr. Ganesh or any of the participants, please let me know. Please tell me. Dr. Ganesh, you're there?
You may proceed, sir.
Or, huh?
You may
Shall I?
proceed. You may continue. Yeah, sir.
All right, please. Thank you. So I hope everybody else joins you when you are saying this. Okay, I believe I go with that belief. Thank you. I'll then close. Let's close in another 10-15 minutes, 10-12 minutes, right? That's okay.
Okay. Sure, sir.
And please try and be attentive. Just very interesting, talk I thought to say with all of you. Tidal power, if we talk of, right? There are these tides. Every one of us knows that we have a low tide and a high tide every day, right? Every 24 hours, we do have low tides and high tides happening, right? In high tides, the water, flows onto the shore from the sea, and when it's low tide, it recedes back to the sea, right? And that is the high tide. We are looking at this picture, and this is the low tide. Okay, the same, this is same construction. This barrage which gets filled up to this point when it's high tide, and the water recedes, and even up to the bottom there's no water then after the low tide. And these tides are occurring because of the rise and fall of the sea levels due to the combined effect of the moon, the sun, and the rotation. And this happens every 24 hours. Okay, so what we do is, can we try and exploit these high tides and low tides? That is tidal power. When the water flows up the stream, onto the shore, try and put up maybe some generator onto these barrages. While the water flows up, it produces electricity. While it goes down, also produces electricity. Okay, so these millions of gallons of water flow onto the shore during tidal flows and away from the shore during the ebbs. Ebbs mean when it recedes back from the land, moves away from the land. Right. The larger and the tidal influence, the greater the displacement of water, and therefore the more potential energy that can be harvested during the power generation. And a typical tidal stream generator looks something like that. This is just 1 megawatt RTT unit. Nowadays, obviously, it must be even higher than that capacity. This is a kind of a structure wherein there's this duct, and this duct, that you can see through. The diameter is something around 15 meters. I mean, look at the diameter, 15 meter. Okay, and the duct length through to through is 19.2 meters. I mean, look at the length of this duct also, through which the water flows up the stream and down the stream, both sides. The turbine diameter is 11.5 meters. Look at the fan inside. So there's a turbine inside this, which when the water hits this duct, flows through this duct, that rotates this turbine, and with this turbine is coupled the generator on top of it through a removable casket, and this gravity base. So this generator then generates electricity, and you can tap this electricity and transmit it through wherever you want to transmit it through. And this happens both sides, and when it flows up, when the water goes up the shore, and when it recedes, this generator generates electricity.
Tidal power.
Okay, there's a video for you.
Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. Tidal barrage is a dam that utilizes the potential energy generated by the change in height of tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air, and therefore has greater force on the turbines. Tidal power is easy to install and renewable, having no direct and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management. This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity, and therefore do not provide sufficient capacity to satisfy demand. That's tidal power. Tidal power.
So I thought to run this video so that you can better appreciate what is tidal power basically. So during these high and low tides only, we try and make good use of these water flowing up and water flowing back to the sea, and we can put up these turbines on the way and the generator set, and we can generate electricity. And as understood, there could be all different kinds of turbines and kind of barrages required, but then there is a very specific site requirement. You can't be having these tidal generating systems installed anywhere on the coastline. No, there has to be certain specific locations where you have high tides going very high. You can store water also with the help of certain barrage or a dam, and then let it flow slowly back to the sea. But then these tides are occurring at certain time intervals, and wherein the consumption patterns around that particular area may not be matching directly with these tide power generation, but then doesn't matter, you can transmit it to some other places also. So there are certain the Reims tidal power station in France is the world's first tidal power station, opened in 1966. There's the Reims River in France, and 1966 saw that first tidal power station getting opened there in that. It has 24 turbines and peak output power of 240 megawatt, and that's really good. 240 megawatt through these 24 turbines way back in 1966. And Sihawa Lake Tidal Power Station in South Korea is the world's biggest tidal power plant with a capacity of 254 megawatt. Right. Advantage of using tidal power, as we just listened through the video, it's predictable source of green energy during lifetime of the barrage. It's very much predictable, right? Precisely these high and low tides occurring in 24 hours when it will happen. You have precise predictions, it produces no green, whereas solar, wind, etc., they are unpredictable. You never know if there's a wind flowing, wonderful, there's a wind energy available. Suddenly, the wind stops, complete lull, right? Absolutely zero power output. So the wind velocity also varies. So with the wind speeds varying, you have a variable power output available, right? And if the wind speed maybe falls below certain threshold, you don't have a power at all. The wind generator doesn't operate below that speed, cut in or cut out speeds and all. And if at the same time the wind speed is a little too much, maybe just kind of a typhoon kind of situation, then also you just have to shut down those power generators. And obviously this tidal power produces no greenhouse gases or any other waste for that matter, so it needs no fuel, very much eco-friendly, not expensive to maintain though. Tidal energy has an efficiency of 80% compared to, for instance, that of solar and wind. It's around 20, 22, 23% only in converting the potential energy of water into electricity. And vertical axis tidal generators may be, as you might have seen the middle one in the video, may be joined together in series to create a tidal fence capable of generating electricity on a scale comparable to the largest existing fossil fuel based hydroelectric and nuclear energy generating facilities. So you can have in a series of these tidal fences put together, could be a large power station in that sense. There are certain disadvantages of tidal power. What is the disadvantage? A barrage across an estuary, I mean that particular specific location of the coastline, that's estuary, is very expensive to build. So construction of the barrage in itself is involving certain capital expenditure, which is little too much, and affects a very wide area. The environment is changed for many miles upstream and downstream, so that ecology gets disturbed. There could be certain species, that flow up the stream from the sea, and some of them, they get stuck up on the land itself, or the species from the land, they get swayed into the sea. Okay, and so that is effect on the ecology, and the construction of barrage is little costly. It provides power for around 10 hours each day when the tide is actually moving in or out. Obviously, both sides you generate electricity, which is not very much, only 10 hours, right? And how about the rest of the 14 hours? You have to, let's say if you're feeding a certain area or locality through tidal power, then for 10 hours it's fine, but after that what happens? So rest of the 14 hours you'll have to see an alternative power coming to that area. Existing ecosystems would be heavily altered with new species moving in and perhaps dominating the old species. You never know, even that happens. Tidal power schemes have a high capital cost. All right, the tidal power schemes have high capital cost. And if you look at the top 6 countries in tidal power generation with the installed in megawatt capacity, South Korea to 54 megawatt, and France to 40, United Kingdom, UK to 40, Scotland 86, Belgium 20. And in India, we as of now don't have a tidal power plant. Yes, currently we don't have. But yes, according to the estimates, we do have a potential of the Indian government. The country has a potential of 8,000 megawatt of tidal energy, and that includes about 7,000 megawatt in the Gulf of Cambay in Gujarat, and something around 1,200 megawatt in the Gulf of Kutch, and something around 100 megawatt in the Gangetic Delta in the Sundarban region of West Bengal. That's the total potential. If we can exploit this potential, wonderful, we should. And the Gujarat government is all set to develop India's first tidal energy plant, and the state government is, for that matter, approved rupees 25 crore for setting up the 50 megawatt plant at the Gulf of Kutch. It's a wonderful initiative, and when it comes up, maybe then it grows further. This is what I was mentioning. Siva Lake Tidal Power Station, South Korea, the world's largest tidal power installation with a total capacity of 254 megawatt. Okay, a high and low tides are made use of here, and this is 240 megawatt La Rance tidal power plant on the estuary of the Rance River in Brittany, France. Right, that's that river, and we do have this, these installations of generators here on this. So we all know that the renewable energy sources are unpredictable, Do you know which is the most predictable renewable energy source? Okay, here's this question, and with that question, I think I'll stop. I'll reach out to you again in case you have some questions, and then after we'll close the session. Okay, answer this question. Which is the most predictable renewable energy source? Okay.
The tidal power, tidal renewable source.
Absolutely right. Absolutely. The tidal energy, almost 80%. You have precise computations available when the low and high tides are going to occur in 24 hours. So that's how it is. Compared to wind and solar, you never know when it's sunny and when it's not, and when it's like wind speed is wonderful flowing and suddenly there's no wind available. All right. So I think, I don't know, I mean, your choice though, but I can keep on. Then there are these geothermal and other things also. But that will go little, cut through personal times and cut through your dinner time also. And I don't want that. And that, you lose out on your personal times and possibly delay your dinners. That is again not good. So I think I stop here, if it's okay with you. And shall I stop here? And then I am available for any questions. I'll be really very happy to respond to in case you have any questions. You can please do ask.
I have one question, sir.
Yes, please. This is who's that? Dr. Puneet Khatri?
Yes, sir.
Which institution you're from?
I'm from BK Birla Institute of Engineering and Technology, Pilani.
Okay.
Yeah.
Please tell me. Yes.
So you have shown one picture of the tidal power plant of the France. That was the first tidal power plant, right?
Yes.
So
Yes.
that power plant is in between the river and the ocean, right?
Yes.
So wouldn't that will be generating the power more than 10 hours? Because from the river, the water is continuously flowing into the ocean.
Nice. That's almost at the point where the river meets the ocean.
Right. Okay. Right.
Right. So there's not much of a current of water available because of the run of the river. Right. It's only when there's this tides in the sea that water flows back and flows down. Right. Otherwise, on that river there must be some hydel power plants anyway on wherever it's possible. But this is just meeting the sea, so around that.
Okay. Got it.
Yes, and I appreciate that almost everybody is like I started possibly when I started my session, it was around 117. You're still 117, so I really thank you for that. I really appreciate that. Thank you so much. And I hope you could get something out of this and some interest in this across all disciplines. This subject of renewable energy is so very essential and so very important for all of us. For the quality life that we can think of on this planet. If we can bring down this carbon emissions through all these renewables, and we can try and have our lifestyles around nature, as close to nature as possible, we can live our life. And if we can try and exploit or maybe use our resources very judiciously, including energy, the life would be really good. And let's be a little intelligent. We are not, though. Animals possibly are better than us in that sense. And the fact remains that any technology can't win over nature. So let's try and be around. Now we're talking about millets. We're talking about the kind of meals that we used to give to the feed to the animals. Now we said, no, you just try and have these rice and maybe wheat. We'll be eating these millets now. So why? Because that is the the necessary for a sustainable life. Our eating habits, our living habits, and care for nature, everything counts. And COVID that shown it to all of us how important it is for us to maintain a good health. If we are healthy, possibly we can face any kind of viruses or anything like that. And if our environment is wonderful, so that's wonderful. So let's be a little humble and caring to not only the humans but also every biological species. Let's try and use energy judiciously, use water, use everything judiciously, and live a happy life. Right. So if that be the case, we'll be a wonderful species moving on this planet. So God bless all. And I'm sure there are certain takeaways, some threads you can pick up and take good care of yourself also. I usually say whenever I interact with my students that at least 24 minutes in 24 hours for good health, and that's the minimum you can do. And if you do not have even 24 minutes in 24 hours, that's pathetic. We can't be, any one of us can't be that busy if we don't have even 24 minutes in 24 hours for doing some exercise, something, yoga, maybe some brisk walk, or maybe some stretching, something. Right. So all of us should be at least devoting 24 minutes minimum in 24 hours for our good health. Right. If that's the case and eating habits are good, I think we'll be a wonderful, healthy life moving around. Right. And the best blessings could be if we can, breathe our last without ever prescribing to any medicines. Wonderful, those blessings. So make use of energy, make use of maybe even air conditioners, but not 18, 20 degrees Celsius, not lower than 24, 25 minimum, right? It should be 24, 25, 26 even. That's comfortable. And not on 18 degree or 20 degree like that. Chill it around and then, use a blanket. And that's misuse. Anyway, sorry, not here to preach you around, but just to share my thoughts. All right. Any more question, or else I just hope I didn't make you suffer. I hope you enjoyed this talk. Okay. You can maybe share through chat also in case there's a question. You can maybe share your experience also of this session in the chat box in case, or any question in case. So I can read through that. With that, it's over to the organizing team, Dr. Ganesh and the team from Bikaner. I can see the chat box in case you have anything to share, anything to say. Yes. कुछ आपको कहना है तो आप कह सकते हैं, कुछ पूछना है, you can ask me. I can see the chat box, there's nothing mentioned, so if there's any question.
Good evening, sir. Raju here.
Yes, please. Yes.
Sir, one question from my side. What is passive solar energy?
Passive solar energy means you're not converting into some other form of energy. If it's a simply heating, so that's a passive thing. Active means you're converting solar energy through solar photovoltaic cell into electricity, right? So passively, as it is, it's available in the form of a heat to us. So if we can use that energy for heating our homes, that's passive, direct use of it in a way, right? That's if you're using it for water heating, for a heating of any purpose, for that matter. So that's a direct use of solar energy. Okay.
Okay. Thank you, sir. Thank you.
Yes.
Sathans,
okay.
sir.
Somebody said you're not audible. Am I not audible? Hello. Yes.
Sir, am I audible, sir?
Yes, you're audible. Please tell me.
Good evening, sir. This is CS Rajoria here, sir.
Rajoria ji, kaise hain? How are you, man?
I'm fine, sir. Nice to.
Yeah, good to see you joined in. We've organized lot many FDPs, and I still remember connecting with all of you. Still very wonderful memories. So, how is everything going?
Everything is going fine, sir. It's very good.
Wonderful.
I
So you
just
keep connecting me.
Yeah. Yeah, I want to ask one thing, sir.
Please tell me.
Yeah, just when you're talking about that NIT Kurukshetra will be self-sustainable in a near future, no? And 2.5 megawatt will be expanding. That's a very huge just like energy.
Yeah. We already have 1 megawatt installed, and 1.5 it's already the contract is granted, so that will be 2.5, and additional maybe 1.5, so makes it around 4 megawatt, and our maximum demand at any point in time is something around 4.3 or so. So we'll be in a way self-sufficient. Yes, truly.
So just like I was just is in this context, if I am not wrong, that just like are we still using the grid power, just like because if we are installing the solar PV, right? So it will be active in the daytime only.
No, yeah, it will be active in the daytime only, and we are grid connected also. What we do is, because 1 megawatt is not even sufficient for us for our consumption, so we still take the electricity power from Haryana State Electricity Board. Right, we have a bulk supply available, but if let's say we have something around 4 megawatt installed, still during night time, either we should have some certain storage facility and that we can make use of our own, or else we'll have to still depend on the electricity board, right? But
Yeah.
during the daytime, if we have excess, we can feed it back to the electricity board. Let's say during summer vacations, we don't have students available on campus, right? Not much activity happening, so we'll be surplus in power, and we can feed it back to the electricity board, and we get paid. We get paid by the board, per unit, like that. So, so that way, it's both ways. Net metering, whatever we are consuming, taking from electricity board, we pay for. Whatever we are feeding back to them, they pay for. In that sense, there's an agreement signed. So, if we have sufficient capacity, wonderful. Why can't we can feed it back to, and we can earn. And so even during night time, if we are taking it from electricity board, still will be getting money from them if we have already given power to them during the daytime.
So in that context, we may say that just like we are having a net zero emission in this context, na? It's like because
Net zero, see, if we, because electricity, supposing we have only solar here, there's not much of a potential of wind power in Haryana as such, or for that matter, that's available along the coastline primarily, but maybe somewhere in Maharashtra and maybe even Rajasthan also, there's some potential of wind power, but in Haryana it is not. But we have the potential for biomass power, a lot of agricultural crops and residues, we can make use of. If we have that facility, then during the night time we can get power through biomass production, biomass electricity generation. During daytime through solar. Wind we do not have, but as of now only solar, and only solar daytime, absolutely not an issue. In Haryana, around this region, Kurukshetra, we do have a very good potential of solar energy, almost. But during let's say rainy seasons, so that potential is not very much. But if we have that storage system, maybe in terms of batteries, and there are these places, maybe somewhere in Australia, there is the battery bank capacity of even to the tune of almost 1 gigawatt. Just imagine 1,000 megawatt. So if we can have a storage facility of, well, let's say some 200 megawatt, more than sufficient. I mean, even during night time we don't have that much requirement. 100 megawatt is also sufficient. So that can otherwise, till the time that storage facility is not there, or else there are some alternatives also available, some additional renewable energy sources. So we can't be in that sense net zero, but during daytime we can feed it back. We are saving something around, if I tell you, with 1 megawatt per month, we are saving something around 11.5 lakhs on the electricity bill. Just imagine.
That's very that's a
11,
significant amount.
that was precisely the figure per month on electricity bill with this 1 megawatt generation. So that's a huge saving, and a contribution back to the grid also, right? But in the times to come, almost every institution, I think this will become a necessity, and we should in fact willingly try and install these facilities wherever it's feasible.
Yes.
Right.
So thank
And
you.
thank you all. Thank you all for your nice, kind words around in the chat box. I can see through. If you like this session, I'm really happy, and I appreciate that.
Thank you, sir. Am I audible? This is Dr. Ganesh Prajapati here.
Yes, Ganesh, you are
That's
the
why I
reason
was not
behind my
able to. I was not be able to unmute myself because I think I have make you host, so that's why all the rights goes to you. That's why I was not able
Okay.
to unmute myself. Anyway,
Not a problem, but
so,
there are people from Bikaner, they can take care of this thing. No worries.
yeah, sir, yes. Actually, your session was really very much wonderful. Started from the Sustainable Development Goal (SDGs) and then question answer session, and then your videos and kind of statistical data. It was really wonderful. The information
हाँ
which
एक
are
प्रयास
there
था
in the.
कि आपके participants परेशान ना हो दुखी ना हो. That's what I promised, and I'll not make them suffer through me, and possibly try it that way.
Yes, sir, exactly. So once again, I'm very much thankful to you from the Engineering College Bikaner side as well as from organizing team. So I'll connect with you for further documents and all. And once again,
Okay.
thank you, sir. Thank you very much.
Thank you, Dr. Ganesh, and thank you all of you, Razoria, Dharmender, and anybody else connected, and all
Yes.
participants. I enjoyed this thoroughly. Thank you so much, and God bless you all. Take good care of yourself.
Okay. Thank you, sir. Thank you very much.
Thank you.
sir.
Bye bye.
Thank you.
Thank you, Razoria. Thank you. Shall I leave now?
Yeah, sir. Please, you can leave now. Thank you.
Okay.
Thank you very
Okay.
much.
Thank you. Thank you all. Thank you. Bye bye.